Okay, 7.3 is we're solving systems of linear equations in two variables. So let me just write that down. We're going to solve systems, right? Notice it's not solve equations. Solve systems of, right, linear equations in two variables, right, in our x and our y. So x and y. So what is a system, right, of linear equations? Well, it's basically just two equations put together or more. So we know the standard form, right? Ax plus by equals c. And again, I can just write another equation, maybe call it, let's see, a, b, c, d, e, f. So dx plus ey. And usually we put these kind of braces around them just to denote that that's a system. But again, this is this is a line, right? If you want to call it line 1, and this is line 2. So basically, you're going to graph the two lines, and the solution is going to be the point of intersection. So the solution, right, of a system, right, of LE, linear equations, right, the solution is the point of intersection, right? And that's what we call our x comma y, our ordered pair. So, right, we're going to graph a line, we're going to graph another one, and we want to see where, okay, it's an arrow. Whoops, let me erase that. We want to know where they intersect, right? That's that point right there. Okay, so that's again a basic, just kind of introduction. I do want to show you some examples in the next video. Let's see, any other terminology I want to talk about? Well, remember that you can graph lines in two different ways, right? You pick your choice. Method of graphing. And the method of graphing, right, is you can use the intercept form, right, or you can put it in slope-intercept form, right, the y equals mx plus b slope-intercept form to graph a line. And the last thing I do want to say is there's going to be three cases when you graph these lines. And the three cases are the following. Well, I don't really need to draw the coordinate system for this. So if I graph, for example, line 1, right, let's call that line 1, and I graph the other line, so line 2, what is the point of intersection, right? That could happen. That's case 1. Case 2 is, what if you graph the two lines and they don't intersect, right? What if they're parallel lines? And finally, what if you graph line 1, and let's see, maybe make this in pink, and then if you graph the other line, right, it happens to be the same line, so it's kind of on top of each other. So here, line 1 is equal to line 2. So you have three cases, right? Case 1, case 2, and case 3. So here you have one solution, right there. Here you have no solution. And here you have infinitely many solutions, right? Because where do they intersect? Here the pink and the blue line intersect right here, right here, right here, right here, right here. I mean, everywhere. So there isn't just one point of intersection. There's infinitely many points of intersection. Here, parallel lines never intersect, right? So there's no solution, meaning the slopes are basically the same. And just, again, the way the book describes it, or in mathematics, we say if something has no solution, we say it's inconsistent. Okay, so terminology. And if it has at least one solution, then we say it's consistent. So this guy, right, case 3, there's infinitely many solutions, so that's definitely consistent. Okay, so I will put up some other examples, or actual concrete examples. This is just kind of a basic introduction, again, the big picture.